Okay, so we're doing lesson 2-6. We only have 2 more lessons in this chapter. And this one is formalizing relations and functions. So basically what we're doing is we're trying to see what the relationship is between your dependent and independent variable and determine whether it is a function or a non-function. Okay, so 2 new words. Domain, which represents all of your X values on a graph or on a table. Range represents all of your Y values on a graph or on a table. So let's look at our first example. We have all of these ordered pairs. And so one way besides a table, a graph, equation, or whatever, to show a visual representation of your points is to put them in something called a map. And so that's what this is. We're going to map our ordered pairs together. So if our domain represents all of the X values, that would be 1, 2, 3, and 4. We're going to place those in our map in the order they show up. 1, 2, 3, and 4. Okay. Then our Y values are shown as 4, 8, 12, and 16. So we're going to put those in this category. 4, 8, 12, and 16. In order to map them, we're going to draw arrows with the X and its matching Y. So this one's pretty simple. So 1 and 4 go together. 2 and 8 go together, 3 and 12, and 4 and 16. They will not always look that neat, okay? And we'll see that in our next 2. So how do I write out my domain and range? Well, my domain is just the list of X values. So I'm going to write that with this little squiggly bracket. 1, 2, 3, and 4. Okay, so if you were to graph this, it would be every number that is on that vertical line for the x-axis. Our range is going to be written the same way: 4, 8, 12, and 16. Okay. So my question is, and this goes back to our last lesson, do these set of ordered pairs represent a function? Yes, because every X value has exactly one Y value. You don't have an X value that goes to 2 different Y values. So we will write yes right here. And we're going to explain. And I am going to show you all kinds of different ways to explain. But I mean, you could write the same thing for everyone if you wanted. So each domain is paired with exactly one range. You could say each X value is paired with exactly one Y value. Okay. Yeah, so those are the different ways you can write it. Okay, now we're going to go to examples 2 and 3. You probably see the pattern. Some of you might be able to fill out your domain and ranges. So let's go ahead and do that. We have all of our domains that need to go in this column. However, before you start writing, they need to go in order smallest to greatest. Okay, so in this case, we have a 6, a 4, another 6, and a 5. You do not write the 6 twice. 2 rules. They have to go in order least to greatest, and you don't duplicate a number. So in this case, we're going to have 4, 5, and 6. Okay. And then in the range, we have 5, 3, 4, and 8. And we're going to put those in order. So we have 3, 4, 5, and 8. Okay, so when we map these, we're going to map them to their corresponding pairs. So we have 6 that goes to 5. We have 4 that goes to 3. We have 6 that also goes to 4. And then 5 goes to 8. So see, this one isn't as pretty as the last one. Now we're going to write out all of our domains. So our domains, again, need to go in order. And you could just look at your map over here to write your domain and range. Okay. All right. Does this represent a function or non-function? Y'all know, why is it a non-function?
Because 6 has 2 values.
Yep. There you go. So this is how I'm going to explain it. The domain of 6, or the x value of 6, is paired with 2 different ranges or 2 different y values. Okay. All right, I want you to go ahead and try this next one. There's decimals in there. That is okay. Don't let it trip you up. Just write them in the correct order. And then we'll come back and we will check our maps. Okay, when you're done, you can go ahead and check example 3. Make sure that you did it correctly. Are there any questions? Yana?
Why is it a function if 2.5 has 2 values?
Because it's only the domain that can't have 2 values. Let's go ahead and go to page 2. Same concept, but now instead of mapping diagrams, we're going to be looking at tables. So there's no difference here. So let's look at our X. Remember, the X represents your domain and the Y represents your range. Okay. So when we write our domain, we're just going to list these in order. So we have 2, 3, 4, and 5. And then our range. Notice that 4 is duplicated. We're only going to write it once. Okay, so our range is 4, 8, and 10. So does this table represent a function? Yes, it does. And then your description, I got the notes right there, is that, and I'm just going to write this a little differently. Each X value is paired with exactly 1 Y value. All right. Can you guys look at example 5 and tell me what you notice about the table? Grace?
It's the same as example 4, but
They're just switched. So I want you to go ahead and do this example and see what you come up with this time. Okay, so go ahead and check example 5, see what, if it matches what I came up with. Are there any questions on this one? Okay, so good. So 4 has 2 different y values, so that can't happen. So it's a non-function. Okay, we are going to move on to graphs. So we've done mapping diagrams, tables. Now we're going to do graphs. So let's go here. Graphs can be a tad bit confusing, so I'm going to show you a way that I do them to help me. I actually place all of my ordered pairs that have been plotted into a table. But I'm gonna show you a way where you don't have to do that, and then I'm gonna show you a different way. So you'll notice that all of these points that are plotted, right? These are just ordered pairs. Those are all ordered pairs. Can you tell by looking at the graph what your x values are? Can anyone do that? Raise your hand if you can. Lauren?
It goes by one.
It goes by ones. So if you were to create ordered pairs, what are your x values in all those ordered pairs? Okay, look at this. We have -1, -2, -3, and -4. So our x values are -4, -4, -3, 0, and 1. However, if you can't see that, then what you would do is you would create a table. Okay. Before I create my table, okay, so I'll go ahead and do this. -4, -4. Hold on. Before I do that, I want to show you something else. Your y values here are on the 2, on 1, on -1, and on -2. I just went down the y-axis. So this would be your y-axis right here. And you can go across like this to figure out what your y values are. And then this here is your x-axis. So you can go up and down to figure out the x values. All right, I'm gonna write them in my table though. So my first ordered pair would be -4, 2. My next ordered pair is -4, -1. Then I have -3, 1. Then I have 0, -2. And then I have 1, 2. Now, before I go on, do you guys see what I'm doing with the ordered pairs? Ellen? No? Okay, so you see this point right here? All right, I want to know the ordered pair of this. So I go over at -4 and I go up to 2. So my ordered pair for that one is -2, -4, 2. Does that? No, no. You could start over here. You could do this one first, that one. It doesn't matter the order. It's just once you put them in the domain, you want them in order from least to greatest. So let's go ahead and you can use this table to create your domain, and they're already in order from least to greatest. So we have -4 that we only have to write one time. We have a -3, we have a 0, and we have a 1. Then let's go over to our range. Now our range is not in order, so we need to make sure we put that in order. We have a -2, a -1, a 1, and a 2. Okay. Now, looking at my domain and range, I can't determine if this is a function or a non-function. I would actually have to look at the graph or the table. Now, when looking at the graph, you will see that it does not pass the vertical line test because this vertical line right here is going through 2 dots that both have an x value of -4. So we could tell this is not a function. But again, if the graph is hard to read, then you can look at this column right here, And you could see that -4 is paired up with two different y values, making it a non-function. Okay. So I'm going to write no, it is not, and then it says to explain. And there's two ways that you can explain. With a graph, we typically say it does not pass the vertical line test. So that's what I'm going to write. Now, if the graph, though, was hard for you to read, you could say something like the x value of -4 is paired with two different y values to a -1. And then that could also explain it. So either way would be okay. All right, let's go down to example 7. Example 7 is a parabola. We're not going to look at the domain or the range right here. I just want to see if you can tell whether or not this is a function or a non-function. Okay, so go ahead and look at this and make your best educated guess, or if you already know it. Anyone want to take a stab at this? Sam?
I think it's no, because it's -2 and 2 at the same time. I think it's not a function.
Are -2 and 2 the same number?
No. Yeah,
So yes or no?
it is.
Okay. He's like, now I don't know what you're saying. Look, here's the vertical line test for -2. Here's the vertical line test for +2. Do they hit the same x value? No. So is it a function? Yes, because it does not, it passes the vertical line test. Okay. So yes. All right, good. Okay, let's move on to page 3. Okay, so we are going to work on domain and range. So we're going to look at a graph. We're going to determine if it represents or what the domain is, what the range is. So here is our line right here. Okay. And sometimes, sometimes it's hard to read the domain and range. It takes us a little bit of practice. So in looking at this line right here, what are our possible x values for this graph? And if it helps, you could plot a point here. And you could say, okay, this point is -1. I can't read that, 5. Okay, let's plot another point. Here's 5, 5. So we have an x value of -1, an x value of 5. We could plot a point on every single one of these and have a different x value. And when you have a line graph where it has arrows going, it goes on forever. So what do you think our possible x values for the domain are in this graph? Infinite. So this is how you would write the domain for infinity. You have positive infinity all the way to negative infinity. Okay.
Negative infinity.
So it goes all the way, well, because it goes all the way to the, oh, I put my negative on the wrong side. It's supposed to be, sorry. I know, I'm so sorry. It should be negative infinity to positive infinity.
And
Fix that real quick. negative infinity. I mean, it's not very nice. It's not very pretty, right? Yeah, there you go. Okay, now look at my range here. I have negative 5, 5. Here I have 3, 5. What do you know about all of our y values?
It's all 5.
It's all 5. So the only range that we have is 5. Okay, so is it a function or a non-function? Why is it a function, just like? Yes. Your x don't repeat. They all have exactly one y. Your y can repeat as much as it wants, right? But not the x. It passes the vertical line test. That's another reason. Very good. Okay, so then let's look at this example 9. Okay, here's our line. And if I were to write down some ordered pairs, I could say, I have 3, 4. I have 3, 2. I have 3, 0. I have 3, -2. I have 3, -3. See the pattern? So what's our domain? I can find domain and range. Which are domain? 3 and only 3. What's our range? Yes, negative infinity to positive infinity. Is this a function?
No.
No. All right, good. So we have done the majority of the lesson. And so what we're going to do now, I've included some word problems. Yay. So what we're going to do is we're going to create the equation and then determine if the equation is a function. So we've done mapping diagrams, tables, graphs. Now we're going to do word problems. So it says that the volume of a sphere is the product, that means we're going to multiply, of 4/3 pi and the cube of the radius. How do we write the cube of the radius? R cubed. We've just pretty much put that in the order that it needs to go. So product, we don't need to write that multiplication symbol. So let's write out the formula. V equals 4/3 pi times R cubed. Okay. Think of our slope-intercept equation. If we put a value into X, will we always get a different Y? If I put a value of, okay, let me give you an example here. Y equals 2X plus 3. I put 1 into the X, I get Y equals 5. If I put 2 into the X, I get Y equals 7. If I put -7 into the X, -14, Y equals -11. Can I ever put a value into X and get a different Y? No, you will always get a different Y. So when I put a value where R is, will I ever get a different volume amount? Or will I ever duplicate my volume amount? No, you won't. So is this a function? Yes, it is a function. Okay, and this is what we're going to write. For each possible measure of the radius, there is exactly one corresponding measurement of volume. Yeah, we'll go off the lines. Exactly. One corresponding measure of volume. Okay. All right. Page 4. Did I not leave room for the equation on this one? Let's see. All right, 11. Each day, the local weather station records the high temperature for the day, T, and the amount of rainfall in inches, R. So let's look at this. Does the temperature or the rainfall depend on each other? Huh? No, I mean, it could be 60 outside and rainy, or it could be 60 outside and not raining, right? They do not have any relationship at all. Temperature and rain, in Texas anyway. Maybe in some states it does, but in Texas, it doesn't. So this would represent a non-function, so it is not a function. And the way that you would write this is that there is no correlation between temperature and rainfall. Okay.
We're doing homework, we say there's no relationship.
Yes. For relationship. Correlation is a relationship. It's just another name for relationship. Because it's a math word that we use.
Between.
Don't. All right. All right. So, okay, let's look at 12. Your friend has a part-time job assembling bicycles for a local store. Each day he earns $20 plus $15 for each bike. I want you to come up with the equation on your own, and then we'll check. Also finish the second part. Does it represent a function? And then explain. Okay, go ahead and check if your equation's right and if your answer is right. And I'm going to. So these last two problems are just problems that students in the past have struggled with on the homework. So what I did is I created a problem that is similar to those two. So let's look at this one. And I want you to kind of think about this one. This takes a little bit of critical thinking based on what you already know. What value of X will make this relation a function? Look at your ordered pairs. What is the value of X that will make this set of ordered pairs a function? I want you to think about it for a minute. I don't want you to sit and wait for the answer. I want you to really think about the difference between a function and a non-function. Okay, Art, what do you think?
It could be literally anything except for 2 and 5.
And why is that?
Because if it was 2, then there'd be 2 y values. 2, like there would be the x value of 2 with 2 different y values.
Yes.
Because negative math would be the same.
Good. I like that. That's exactly correct. So any number other than 2 and -5. Good. You should ace that problem on the homework.
Is that the exact problem?
No, I just changed the numbers, but it's very similar. Okay, 14. Jack drops an egg from a 3-story building while Jill records the height every 2 seconds using a video camera. Is height a function of time and seconds? And explain. Remember. Okay, it's a science experiment. Archer did this last year. He threw an egg But it was protected. Am I recording? Make sure I'm recording. Okay, good. All right, so does the height depend on the time? So does the height of the egg in the air depend on how long it's been in the air? Or does the time that it's in the air depend on the height it's at? Ooh, we've got a debate. Okay, we're gonna pause the video for a minute. Okay, so we have come to the conclusion that time is the independent variable, whereas height is the dependent variable. And what that means is that height depends on time. So height is a function of time. So I want you guys to understand this. Height is a function of time.
On the homework, is there also the answer is yes?
Okay, so you would put that at every interval of time, the egg will be at a different height. Does that make sense? That means that your time amount, see when the height goes from here to here, your X value on the time will never have a duplicated height value. Okay. All right, that concludes lesson 2-6.
Interesting lesson.